Hey, Coffee Compiler Club, here today to talk about compilers and language runtimes and medical treatments for frozen left shoulders. Everyone's being recorded. It'll go up on YouTube in a couple hours, and I will summarize the last 5 minutes of shoulder survey, which was the 20-year orthopedic surgeon told me there's no scientific evidence of exercise helping with a frozen shoulder. And also, she was intensely curious as to whether acupuncture was helping. When I go to acupuncture, it is clear when I come out for the next several hours, I definitely feel looser and more pain-free. And it appears that recedes over the next week, but I'm clearly week by week better. Is it a local thing only? Is it part of the long-term healing? Frozen shoulder always heals in roughly 2 years max for everybody. Sometimes quicker, sometimes less, depends on the person. So I also doing some exercises that also seem to help. So no evidence. Scientifically, my personal take is acupuncture helps. Shoulder exercises help. Fine. Enough on my medical issues. Something else. Levo was talking how to do. I threw slides in the link, Levo. How to do SSA-based control flow optimization things or something. You're just talking about doing an optimizer. And did you want to talk about that, or are you happily settled on what's going on there?
I just want to know what would be the most profitable. And yesterday I was thinking, what do you mean by loop transformation? Because I'm assuming this is not a moving or code motion.
Yeah,
So
it's not.
I
Okay,
just
so
didn't know why that was profitable or what's
right.
involved specifically.
Okay, so let me hit the obvious code motion question. So when I go to sea of nodes, I lose placement on purpose of where things land in basic blocks, and I ignore that while I do other optimizations. And then there's a code motion algorithm that comes later that covers all loop invariant code motion style optimizations all at once. So it'll take any arbitrary block frequency and do placement to minimize things in the maximal block frequency. And if you do a heuristic for frequencies like C does, where you just do loop nesting depth, then it does loop invariant code motion. Fine. When I say other things about SSA and loop algorithm, loop changes, I mean bulk loop modifications where you take a loop and make a second copy of the loop body, and then you have to restitch all the edges such that they're correct. So as an example, suppose I want to peel a loop iteration. So in the land of how do you peel something, the easy cut here is I have done a placement using the code motion algorithm, just using loop nesting depth. I now have a list of ops that are in the loop body, and all the other ops I don't care about. I just want to know who's in this loop body. I then clone them all. I get a new copy of them. And I want to stitch them such that their control flow aligns up. So the control flow that says I enter the loop, I restitch to enter the peeled part. The control flow that says I exit the peeled part would be an exit loop kind of thing, or a trip back. The trip back actually goes into the real loop, not the peeled. The exit has to merge at a new exit point that's post the other loop. So you end up with where you had a single loop body, you now have two, however you want to do it, two, but this exit has to exit the same as the original would have exited. So it has to come down here. The down here loop has an exit. Now you have a merge point down here. So values that are computed up here and values that are computed in here, if you exit, have to merge down here. So you have to find all the guys in the corresponding pieces in two different loops, force a merge for them down below. Force a merge means put a fee in. Put a region node, put a fee in for everybody who's going to merge there. That kind of whole graph lineup is complicated. So to make it more complicated, you can have multiple control flow that flows back in, or exits, because you can have multiple exits out of your loop. All of those staggered tree of expanding control flow coming out of the peel has a tree of expanding control flow coming out of the main body. All those exit points that actually exit have to also be stitched up. They are non-trivially non-local. That's the single most complex thing I think I do in C2, not counting the register allocator.
That does sound really annoying.
It's roughly annoying, yes.
It sounds like most of the profitability is just unpeeling the first iteration. Is that right?
No, the loop optimizations turn into this exponential speed up of just the loop as you do more things to them. So you start by moving invariant code out, you get some amount of speed up. Then in the land of Java, you have all these safety checks moving them out, gives you this another round of speed up. Now you're looking like C code. And if you have a tight C code loop, an x86 does so much. But if you unroll it, get rid of the extra trip test exit, and have twice as many ops, you typically can fold a bunch more, and an x86 will go half again faster. It's a large speed up on this loop. So if the loop is really running a long time, if you unroll it enough, an x86 will keep picking up 50% speed gains, and with some diminishing returns until it gets sort of too big and you're done with it, which is probably roughly the size of a cache line prefetchy per iteration kind of thing if all the arrays line up. Then you can get into SIMD ops, which will give you another doubling or tripling or quadrupling. So you
when
can
you say
take
too big, you mean an instruction cache miss?
If you get much too big, you'll get an instruction cache blowout, and then you lose big. Yes. But if you get beyond a certain point, an x86 will have maxed out his pipes, maxed out his prefetch, maxed out, and he's just not going to get any faster. He's doing this 4 wide issue every step through because he's all delayed out of order sufficiently far enough that he's packed his entire queues up and he's doing the max that what the hardware will do. Then you can put assembly ops or vectorization, AVX, whatever the fuck, and get another 2, 3, 4x. And then you're probably out of bandwidth. There will be diminishing returns eventually, and you may or may not blow out your iCache before that happens. But some amount of unrolling keeps speeding up these loops that are, if they're tiny. If they're big, if the loop has a call in it that happens every iteration, you have to inline the call or you lose. You're dead on the call, right? But the loop's modestly sized and long running, yeah, you want to keep unrolling it, not just once, but twice, 4, 8, 16 times. Fold it up, start looking at SIMD ops on it, force some alignment by the peeled pre-loop. The peeled loop becomes, the peeled iteration becomes a loop instead of a peel. So doing once and then falling, you peel it where the count is force cache line alignment, force power of 4 easy alignment. Now you can SIMDIs in the next loop. So loops that have long running, fairly regular structure can get these enormous speedups. They're not super common. Certainly in the land of Java, they're not, unless you're doing, a big data science project. But they happen. So if I'm nomming down giant network vectors of streaming data, there's a thing to be done there. If I'm plowing through Goldman Sachs risk analysis, all written in Java because I totally worked with them on that, then, there's something to be done there. So it happens. If you're writing C code, there's a reason people reach for C and Fortran. They get these crazy loop things going on, and the loop suddenly runs 10x faster. It's a big number.
There is one more pedestrian use case for loop unrolling, and this is fully unrolling the loops that are small. Maybe you have a programmer that wants to write a simple code. Say you have 3-dimensional point and you want to do something for coordinates X, Y, Z. They just want to write this as a simple loop. They don't want to copy paste the code 3 times because the compiler can do the copy pasting for them. So basically enabling simpler programs can be a good use case for loop unrolling.
Yeah. Another one is the network byte reversal where you have a loop of 4. You see all these short loops with fixed bounds, max unroll, and then there's a bunch of loads and stores.
I thought that was just XCHG.
Depends if you're writing it in Java or not.
I've played that game before where I went through and replaced a bunch of functions that were looping through the 4 options to just handle north, south, east, west explicitly for in code. And then you recompile and it generates the exact same assembly. And you're like, well, that wasn't a good use of my time.
But you learn something. Not all compilers will do it right. So, these days maybe that they will. But certainly when I was hacking, you couldn't trust GCC to unroll and optimize completely away there. Maybe not, it would vary by platform.
It turned out if I said exactly for I equals 0, I less than 4, I plus plus, it figured out, yeah, this is 4 times, and it went away.
And it did.
If I did some for each mappy thing, it didn't always get it.
It didn't know, yeah, it didn't know what to do. Yes, yes. Well, I worked hard to land a Java to make simple iterators collapse up until you have nested iterators objects for each iterators, and then they alias on each other, and then it doesn't necessarily help. These days it might collapse still. When I walked away from it 20 years ago, I had 1 deep would collapse and 2 deep had aliasing issues.
If you feel like commenting on a switch optimization, I can show you some code.
If you want, that sounds like a good thing to do. Fine.
Sure. I'm gonna put in the link on the chat.
Yeah, I see you hit Godbolt in the chat. You're trying to
curious,
optimize. Yeah, you have a very unrealistic switch statement. But
yes.
Fine.
I was just messing around. Just
you're trying to see what somebody does. And dummy is your hide it from, yeah, void int. Okay, fine.
Yeah, so the idea was I want to see if there's an optimization when the cases are a power of 2. I want to see what happens in the third one where I have a bunch of integers, and I want to see what GCC and Clang would do differently.
Right.
And test 2 seems to use a lookup table, or a lookup table, and I was like kind of surprised. But
why was
they all acted differently.
One has a tree breakdown. That's interesting. Where's 2? 2 does the lookup table because it's pulling the return value straight out of the table. It is literally not calling code. It is loading the return result. That's an interesting optimization. I don't believe I put that in C2. And then the third one has a breakdown, a breakup table. So an if tree, a switch tree. I think he's switching on a tree. Is he doing? Yes, he is decreasing values, increasing values. Yeah, he has a classic if tree. All right, let's go Clang here. Number 1 is he puts a switch on you, and he loads the constant and calls the dummy. Really? Oh, so he moved the value that dummy calls out of into a table.
I was very surprised of how different code they emitted.
Well, those two make sense. And the third set is a little weirder. Let me stare at the test 3 on Clang. Like on GCC, he's just sorted the values and he's doing binary search in an if tree. And this guy he's doing some kind of binary search.
One only does a single compare with a jump, and then the other one does a compare and then 2 jumps, like greater or equals.
Say which test case, GCC and test 1, 2, 3. Which one are you talking about?
I think it was Clang that did. Clang test 3 does only a single compare and a jump, while GCC does a compare and then 2 jumps.
Clang test 3 has a compare against 31,110 jumps. He might,
you know what?
He gets he gets several jumps.
Yeah, I was looking at a different architecture, so GCC generated different code this time around.
Oh yeah, I'm certain. You can pick. We throw another link out or whatever. You change architectures, you change whatever coding style makes sense.
Yeah, I don't remember what I looked at.
But in the lack of interesting profile data here, I think put the 1, 2, 4, 8 numbers in a table and load them is a good answer. But on the large counts of random numbers, I think you're kind of stuck. There's no good answer. The if tree breakdowns are probably as good as you're going to get.
Are any of these particularly bad? Because I didn't like how I wanted to avoid lookup tables since I realized most of my apps are a memory bandwidth. I don't have enough memory.
Before you finish, Cliff, when you're talking through the examples, maybe share your screen so it gets captured in the video for anyone.
Oh,
I always forget to mention that.
Fine.
But now I remembered. So.
Yes. Okay. Let me do that here.
I pre-looked at it, so I knew exactly what Cliff was.
No. But we have to think of future watchers. That's the
future
point.
generations.
Future generations. Yeah. Okay. So I'm going to tag the data really quick for future generations here. So here's test one. He calls dummy on some random numbers with these nice short integers. Here's test two, which, you know, returns the numbers directly. You could, in fact, do some math on them if you thought about it, but the compiler's not, because the math seems pretty arbitrary. Test three has large count of weird integers. So go look in the generated code. GCC test one is looking like a straight up equality check. No, it's a balanced binary tree kind of thing. Compared to 4, jump goes to L2, which is somewhere down here. He's going to, he gets the right answer directly. Otherwise,
I
he
kind
jumps
of don't
straight
like
to
how
L2.
many jumps are.
Speaking of balanced binary tree, there is a nice trick. Click on this plus icon in Clang, for example. Do you see this plus under Clang 16?
Clang 16, I see the plus, yes.
Yeah, click the plus button, yes, and click Control Flow Graph.
Oh, ha, ha, ha. Oh, there you go.
And now select test 3. You have a drop down that allows you to switch to the test 3. Currently, it's set to test.
Okay, I'm looking
yeah,
for
the
how
top
do
right
I
panel.
find select test 3?
On the top right.
On the top
on
right.
the fourth, yep.
Oh, I
It's
see it now.
right under, exactly, right
Oh,
under
we have window.
and now you can see the tree.
Yeah, now I have window width issue.
You can also zoom out and zoom in.
Oh, geez, fine. That looks like a balanced tree, though. Very clearly a balanced tree.
So Leva, when you say you hate jumps, just to be clear, there are jumps and there are jumps. So conditional jumps cost something potentially.
Yeah.
Unconditional jumps cost nothing usually.
Yeah. So specifically, I was reading
predictable versus unpredictable. I would say it's the predictable jumps that are practically cheap.
They're
unpredictable.
There is someone in the lobby, I believe. Did you let him?
Oh, no, chat. What the hell is my participant list? It doesn't. He didn't. No, I get a warning if somebody's in the lobby. I don't show anybody.
Adrian has right.
No, and somebody dropped. It probably had a bad connection, and then they'll be back in a minute.
Okay.
Yeah, right.
Watch for him. I will.
Okay, so let's go.
I think I gotta clarify the jump thing though.
Yeah.
Okay, so
Adrian's back.
I was rereading Agner Fog, and many architectures seem to do at most 2 jumps per cycle, and if there's more than 3 in a 16-byte line, it doesn't perform as well. So I was thinking of doing a binary tree would be much better than doing a bunch of GCC.
Okay,
it does
so
many back-to-back comparison jumps.
Levo,
I was thinking binary tree might be better.
You have to be careful with looking at the fog got stuff. It's correct. It's also micro scale, and you'll get much bigger numbers out of sort of macro thinking and macro work. And when you get down to the micro scale, it's useful to pick up that last little bit, but it's not where your big money ever comes or goes. For instance, you pull out these switches. If they execute very infrequently, then it doesn't matter what you do for the coding on them. They're just not important. And you should spend the fewest number of brain cycles to make it functional and correct, and move on to higher performant optimizations. Right. So in the land of I'm just C code and I don't know anything about what I'm looking at, performance or profiling wise, he tries really hard because he's had 40 years to try hard, but he needn't bother if it's just actually low frequency. No one's going to care. In the land of I have profile guided optimizations and I know something about these branches, including I know a bunch of them are really hot, then you want to sort them according to the profile, which you don't have without profile data here. Normal C doesn't have it.
Oh, I see. I should be thinking about how to optimize it when I have a profile, not before that.
And as soon as you have a loop, you have a profile. You have a strong estimate, a good strong estimate for loops in C code is they execute roughly 10 times. Unless you can see that it's a blatant DAXB, SAXB, LinPack style loop, you guess 10 per depth. And then as soon as you said, I have 10 times in a loop and the switch is in the loop, I want to do something about it. And if I have the switch outside the loop and a loop that goes by 10, I don't fucking care what I do for the switch. I want to do loop invariant code motion. Right? That's the thinking I'm trying to promote here.
I see. Yeah.
So it's interesting to see the different styles you can do on switches. Every now and then, someone writes a really hot piece of code like parsing in a compiler. And we're all compiler geeks. We all write parsers and compilers, but it's not a common thing. So you write parsers in a compiler, you have a switch on the characters of the text of the code you're parsing. It's interesting how the switch gets laid out, and you care. All other benchmark optimizations people on the planet will see essentially no gain from such a work. So this is all for you when you parse your own language, or for me when I parse Java or AA or whatever. But it doesn't really impact hugely, typically. You got profile data, you'll find the hot ones you care. If you don't have profile data, So
yeah, I got to start thinking about how to collect and generate profile data. But one thing I was thinking about switches was there's a thing called like parallel bit extract. It has a latency of 3, but I was thinking if I could pick out 3 bits or whatever amount of bits from a switch, from the values in the switch, in the case values, I can probably just have some kind of lookup table because I only need like 3 bits for the 8 cases or whatever. But anyway, I was thinking maybe that's like overkill for most cases, and then you just said only compilers care about switch tables.
Right. So as a for instance, go grep the Java JDK for switch statements. It's a lot of code. It's a grep. In 30 seconds or 2 minutes, you'll have a bazillion switches. Go take a look at what they take for their cases. And you'll see the kinds of things that you might want to switch on that people actually use. Let me go, where was, control flow. Let me get rid of the Clang one here and then zoom out. So here's, this is probably test 1. So this is a 1, 2, 3, 4 test GCC first case, 1, 2, 3, 4 in a row. He just fell through. And honestly, it's not a bad answer given the shallowness and the predictability. Test 2 just did a table load. There's a range check, make sure you're in bounds of the range, and then you load from the table. That's totally awesome.
Can you can maximize it, only this section. And, no amount, a little here to the cross, and you can maximize just this window.
How do I, okay, I'm missing how I maximize this one window here.
Up and right. Up and right. Yeah, up, no, down.
I meant zoom out, which way?
No zoom out. You can just
it's Windows. It's got the maximize box.
Yeah, no, it's not this.
That one. Down the little one.
Oh, this.
Yes. Bingo.
Holy crap. Well, there you go. That looks like a fairly reasonable, balanced, semi-balanced binary tree kind of thing. He has two arms. There's a left spline or a right spline going down. There's a second. I can't grab and highlight. There's a second spline going down. I don't know if my mouse shows up on the recording or not.
I think I like this technique the best, but I was just curious what your thoughts were.
Your mouse shows up.
Okay. Yeah, so right. So I guess all I'm saying is, sometimes, burn your dollars elsewhere. When you have a fully fledged, good optimizer already running, come back and revisit switches. First cut, I would do a dumbass if tree and walk away.
One thing with the LLVM code, I think it's a little bit smaller because it doesn't generate repeated calls to dummy. If you just compare side by side, it's actually going to only call the dummy function once. And
the LLVM guy, the Clang one, has a really cool test 1. I was very surprised. This code.
Right, but also compare test 3 with GCC and LLVM. What's different for LLVM is you only prepare the argument to the function.
And then you call dummy once.
And then you call it once. So it generates much smaller code.
Yeah, it's a good one. He's done some sort of tail call elimination. In the land of C2, we would see all these merge points at the break statements from the switches. And I always peeked up through them to look for common operations that I could sucker down as a outlining code reduction thing. I don't have a set of fees, but if you have, you have one merge point, it's a bunch of fees. Here it's actually one exciting fee. It's merging 8 paths. Everyone up the path has something in common. And then they have a call dummy, and that's all on every path. You can pull a call down below as a people optimization, call dummy once with 8 arguments coming in. I don't do it for calls, but I do it for other ops as a code reduction. But it could work on a call.
I see plenty of code generation that Clang does that I think is better than GCC. But every time or specifically for my compiler and for your CSV challenge, GCC was better, and I don't know why. It's complicated.
Yeah, it is. And that's the trick. It's complicated, and playing the game of getting one benchmark to run super fast is exactly a game. In average, it's statistics, it's a large corpus, and the goal is, on average, how well do we do across everybody's things? And when you hit the on average case, you lose interest in the individual tiny micro benchmarks. And so they get what they get. They get the average case, which, on average, I think Clang probably does better than GCC, but GCC's been around a long time. It's not a bad answer. It's missing a few things. It's got a few things. Everyone does a little bit more, a little bit less. GCC's not doing the call dummy shrinking thing. But you can imagine another case where GCC does something and Clang does not. And if you write the micro benchmark that points it out, you'll say, ooh, this one's better than that one. But on average, they kind of wash out. Who knows?
I want to say something about it. Can you hear me clearly?
I can see you. Did you want me to give you the...
No, can you hear me clearly? I'm at an airport right now, so...
Oh, yeah.
I can hear.
Yeah, so I wanted to say something. Basically, in the chat, I posted a PDF on like how LLVM does like switch lowering. It's an older paper, but
better not be porn. There you go.
So the interesting thing is, you mentioned branch trees, and then you also have like on the other side, jump tables, but you can also have these radix trees and things, and binary trees with a custom pivot. And the interesting thing is, like so much when it comes to like the switch lowering, and in selecting pivots, is dependent on getting really good profile data and also knowing your microarchitecture, because like the depth of these branch trees, like how far you can go, depends a lot on the branch predictor and other things, and like how big certain buffers are. So like it's super difficult to get, first of all, like high quality data, and then make statements that like range across lots of architectures. So
I'll agree. Java has the benefit of having typically good profiles, but then same as LLVM, targeting a wide variety of architectures in the back end, and that depends on whether you want to do things like, if number of cases is less than 3, then emit branches. Else, if it's small and unique, then do bits. Else, blah blah blah. A lot of them. We do roughly this. I think we're not doing emit bit tests.
I think John Rose told me that less than 7 or less, they always do nested ifs.
Yes, that would be the case where 3 is replaced by 7, but the heuristic's identical. We do a thing where if we find a pivot and then we recursively do either side, which turns into jump tables or piles of switches or ifs at the end. So we're doing similar to the LLVM with a little bit different constants. And I don't know that the bit tests are in C2. But that's roughly the same thing. And while this is really cool, again, first cut, do loop invariant code motion. Second cut, get your inlining and your register allocator up to snuff so you can inline aggressively and register allocate well. And then start headed for like anything fancy with switches. Otherwise, you can look at this, say, that's really cool, and I'm just going to do the emit series of branches. Until you get it, until you get everything else sort of hammered out.
By the way, Livo, have you ever talked on CCC about what kind of programs you're using to actually benchmark?
I just use perf on Linux for the most part. sometimes I use coverage to get an idea of how many times a certain switch case is being executed. But yeah, that's pretty much it. Like I don't go too much into detail. It's just
when
whatever
he
perfect
said
is to me.
benchmark, I thought he meant what is the corpora of things you run to decide whether your optimization made things better or worse on some giant corpora of this is what the world looks like.
Yeah, Bolin or C. What's
Well,
your yeah, you don't have enough Bolin programs.
Yeah, I don't optimize my generated code. I just use LLVM to do it. But when I optimize my compiler to get my compiler fast, I just like throw random dumb tests, like micro benchmarks kind of thing.
You're now what's the corpus fed to your compiler, and you want to have a wider variety of things, so your compiler doesn't get hyper focused optimized on compiling grep or whatever it is you're compiling.
Well, I only did it for my my heaviest function, which is building the AST, and that's pretty much it.
That's what I'm saying. Get a broader set of things.
That was a real advantage of Java, is that they've had a meaningful corpora to test against for decades.
Yes. Yeah.
So I was kind of curious about how like like generating reports for profiles. Like, what do you have to have in your binary to generate it good? Because I was like thinking it's just executed code, and I mean executed lines, and like maybe that's it. Like, what else? What other information would I need?
What do you get out of other people's profiles? You asking how to gather the data that you put out, or how to present what you gathered?
I'm talking about if I want to do a program guided optimizations, what do I need to put in the binary so I can get data, like a profile data?
So you start from what do you want to do with the data? You want to guide some optimization. So in the land of like C-like languages, I'm going to put Bolin in the C-like language category. I would start with, I wanted to have better inlining decisions. Better block frequencies, better inlining decisions. Block frequencies, they kind of go hand in hand. So then the easy first cut is I want block frequencies so I know where my hot loops are and where cold loops are, and where I can ignore and where I should inline. And then how do I get loop frequencies? Okay, so the first cut profile data at C2 hotspot, not C2, just hotspot is you entered a function and you took a backwards branch. Those are the two places you put counters. One of each counter per method, so multiple backward branches collide and get confused. That's an interesting first start. So static counter space per function, and you just do an increment instruction when you enter the loop on the counter, and an increment instruction when you take the backwards branch.
And an adaptive JIT has an obvious cheat mode to it, which is it's not limited to one code implementation, right? It can add more and more. It's like, okay, I called this thing 10,000 times. I'm actually going to rewrite that to get more profile data inside of it. And this other thing that called once, fuck it. I'm not even going to JIT it, like.
Right. And it's 1,000 for C1, and C1 includes a lot more profiling data because it can profile vastly cheaper than the interpreter. And then at 10,000, you go to C2. But at 1,000 trips, you go to C1 and you get much higher quality profile data.
What happens if, well, I don't know how many layers of JIT you have, but does the last layer have any profile, or does the last layer gather any profile data?
The last layer only gathers profile data if it has a failout. On every failout path in the last layer, the C2 layer, there's some bit is gathered saying this fucked up, don't do it again.
I see.
Manas, you have your hand raised. Did you mean to raise your hand? You're muted. Okay, you did not mean to raise your hand. Fine. Yeah, your hand's raised on Zoom. I can probably reset it as host. It looks like
I asked enough dense questions, and I don't think I have another.
Next topic.
It's fine, yeah. What were we talking about on Discord? What are the 7 optimizations you have to do, or 8 optimizations you have to do? And somebody had an answer, and I was like, sea of nodes covers half of those, but the other half are totally legit. And it was something to do with loops, register allocation, good. Inlining is good. Sparse conditional constant propagation is good. What do we have that other list? Where was that? It was on sea of nodes chat.
Yeah, I got a
I
list too.
posted
on my
that list. I posted that list like a year ago. That
Yeah, well,
has
it
a-
came around again. That's what I was talking about.
Yeah.
One of the
And
areas I've
what's-
been spending a lot of time thinking about is, so I feel like a lot of the win you get is from inlining, particularly on the big code bases I've worked on. I don't tend to have giant loops that run 1 billion times and need to be 8-way unrolled. I tend to have 10 billion function calls.
Yes. No, that's especially true in the land of Java, or maybe these days everybody does it too. Yeah, inlining is crucial.
And more, what I want is systems that are doing the inlining at much higher levels of abstraction. So a lot of the systems I've worked on are like,
You're also
I
using
need
Python,
to
right?
call this check password thing. So now I'm jumping over to another service and getting back the token. And then I need to get their cookies. So I call another service and I come back with a token.
Well, there's your
and
problem.
then I need to find their friends and I call another service and I come back with a token. And suddenly I've got 4,000 microservices and 1,000-way fan out on a request.
Right. There's
what I
your
really
problem.
want to inline is to turn entire services into libraries where I call that microservice and say, go ahead and give me the code you would have run had I called you, and I'm just going to call the database directly.
Hang on. Hey.
Like,
and
it seems like this is the kind of thing that might be possible in Ecstasy, to say, hey, just move that entire container onto my box because I call you like crazy, and then inline those into the same process because I call you like crazy, and then inline the functions and boil the whole thing away. Like,
that was my subtle grin going.
Right. This is the Ecstasy model. All your services are belonging to us, and now we can.
But yeah, that's still
right.
years.
But the fact that I can't move services from one box to another box, like that's the inlining I really want, not inline this function.
Okay, yeah.
Aaron, hint: you cannot move services, but you can move functions. You can serialize the function and return it to the service that triggered some trip count, and that's is inlining.
All right, I want to give Cameron also a turn because Aaron, you and Cameron were both talking at the same time, and I heard you, but not Cameron. So Cameron, go.
I'm sure Aaron's speech was more intelligent. I was just saying it's still a couple years away from us before we actually get to that. But that's certainly one of the concepts we were thinking about during the design process is microservices are great for a lot of reasons, except reality, right? So it's like the concepts are good, but the way that we actually roll them out logistically is pretty piss poor. So if you could get all the benefits on the development, testing, et cetera side and not have the giant drop off in performance on the runtime side, performance plus efficiency plus size and everything else, it'd be pretty cool.
So in the land of H2O, we passed jar file data around in the cluster. So we could it would in fact run all that code locally.
Yeah, to your earlier point, Aaron, with the lots of function calls issue for performance, was that also kind of a Python specific thing? Because Python has a fairly steep overhead on each function call because of the dynamic capabilities that it represents.
So most of these systems were written in Scala on the JVM, but it was my Scala JVM is serializing thrift to a bunch of bytes, and then your Scala JVM is deserializing thrift back into a Java object, doing a tiny bit of computation, reserialize, like, it is not uncommon for the microservices to spend more time doing serializing and deserializing than they spend doing the actual work.
Well, there's your problem. Quit using thrift.
It's what I used to joke about in the early 2000s about the XML, the web service to do addition. Yeah. Because it's like, because we know what scales, right? Everything scales if we make it stateless. And it's like, okay, let's think of all the useful stateless things that we do. We've got addition.
Yes.
Hashing. Addition. That's all I got. Like, you know, so
That
you build
nearly
an
broke
XML,
the GPS system.
right? So
When
you
they
build an
made
XML
GPS
document.
satellites V2, they were sending back XML documents. But because it had to be compatible with the GPS version 1, it was sending back XML documents that contained a UDP packet tag, and then the contents of a UDP packet, base64 encoded, and then close the tag.
Yeah.
Just sounds terrible, terrifying, something.
I saw a video of a guy in 2005 joking that since people can't put together an installer properly, they're going to start shipping VMs. And then containers happen. So he wasn't too far off.
I mean, statically linked binaries are great.
So there is a theory here that says that your Scala handshaking to the other Scala adds a layer above thrift. Really, you can do better than thrift, but add a layer that says, I need to do something, and I'm going to hand you this thrift packet, which includes the notion of work, and you're going to look at the work and hand it back. But because we're a layer up, let's do the little meta discussion. Can you just hand me the fucking jar file? Hand me the class file.
Well, I want two things. Hand me the jar file that says what to do, because you're not actually a service, you're actually a library, because you're not stateful.
Yeah.
And
right.
two, I would like to subscribe to updates. So if this code ever changes, that you send me a message saying, hey, invalidate all that code and get it again.
Yeah.
And that's what I need. I need the function and I need a subscription that invalidates it.
Right. We at H2O didn't quite do that, but we were kind of close. We would certainly handle rollovers, and well, we just create a new class, so that was unfair. We could handle it. Infinite new classes showing up would get their serializer constructed, and then the handshake would go at whatever speed.
The problem
That's some of the
here,
worst complexity in Erlang is, when do you swap code for the new version of the function?
Yeah. So you need.
I believe there is another problem here. When you send the jar doesn't have a structure. It has a code that it needs to run. So how do you maintain that notion? If you made your application in some way, you need the types, you made your structure, how can you send a jar file with just this functionality? You don't know what's in the jar.
No, the jar implements some interface that has a callable that has a fixed API that otherwise would be sending in the thrift. So the thrift was said, I took a Java object of type foo, I thrifted it down to some bits, and the other guy handled it. Okay, I have a foo, I want the jar file to have an interface which takes a foo. Okay. It makes an interface class with an implementation that takes a foo, and I call the call and foo. This is totally what we were doing in H2O effectively. You mean
in the interface, instead of doing an RPC, inline that code here, encoding.
I get the jar local, I do class for name on it, it loads it, it has an interface it implements.
Okay,
that's call that interface.
But you can only inline at this boundary, at the interface boundary, or?
Yeah, but that's good enough in the land of C2 who does profiling. If I have one implementation of an interface and I have an interface call to it, you better believe it'll go. If you got two in an interface, it's screwed. You know, if you got one interface, you betcha.
Okay. My point being that doing this with function would be much more streamlined, much more type in a way, because the functions are typed.
It's how does he do
right? But I still need an interface definition language to say, here is the border. So the reason we have 4,000 microservices at a company is because this team and this team need a hard abstraction line that says, this is the interface that you use to make the call. And we can do whatever we want on our side, and you can do whatever you want on your side. And
if the interface
we don't have to talk to each other.
Includes an API of calls and types that you both agree on. So you have to have it agreeable to the shape and the name of the type that you're passing into the interface.
Yeah.
So that's the API call. Then, you can pass those over the wire. You can arrange a layer that passes them over the wire and does that.
Right. And that gives me that strong boundary separation, which is what I want to keep team A and team B as separate teams at the company.
Yeah.
Which is the reason it was in a microservice in the first place. But I have the overhead of a function call, or maybe it's even inlined away. So I don't even have
there's another business model here. that says we just have yet another microservices framework,
Mhm. Mhm.
and we make a better microservices framework. It's
Yeah,
just
I
the
kind of prefer having the other microservices be on the same box, so you can do something like sharing memory. Like I
no. The
don't
goal
like
here is to
serializing.
the microservices. If the microservices is state free, which apparently many are, the goal is to actually move it inside the process. And then the optimizing in the JIT turns it into a direct local call. It's a direct method, and you're already hugely far ahead. You skip the network traffic, you skip the serial, deserial. It's a huge win already.
Yeah,
If the distinction between microservice and library goes away for a stateless microservice.
Yeah,
that'd be nice. Yeah.
And then of course most microservices are stateful because they have a database tied to them, which makes things a little more complicated.
yeah. What are you
Yeah,
thinking, Aaron?
mo-
Now, if you have a stateful microservice,
There is a much
Right. So
There is
you pull it. I have two anchors. I say, I'm trying to do this piece of work, and it needs data from database A, data from database B, and data from database C. So my work is going to end up in 3 clusters. The things that all got moved to data location A, the things that all got moved to data location B, and the things that all got moved to data location C. And if it was 25 services, well, it's actually going to run on 3 boxes, the box with data A, the box with data B, and the box with data C. And which things end up in which boxes depends on who does the most cross traffic.
Right, which you could totally get with profiling.
Does anyone here regularly work with microservices?
Hey, Aaron. Not me.
Okay, because is that like a long time ago? Because I thought you were doing something different now.
Yeah, I thought you were doing
Aaron. So Aaron, your question is to Aaron.
for you, Aaron, a compiler question, or what were you doing talking about a month ago, 2 months ago about optimizing Python or PHP or something? Thought you had
I was being jealous of PHP and that it actually did a very good job of things that weren't running, not consuming resources.
Okay, fine.
Whereas a lot of the microservice architectures that I was seeing would keep 10 gigs of data in resident memory at all times because it needed the cache, and otherwise it was sucky slow. And
10 gigs was micro.
A shocking number of the microservices ended up being essentially memcached plus library.
Right.
Because it was just keeping a bunch of data memory resident so that you could get access to it fast.
Right.
So our microservices tended to fall into 3 categories: totally stateless, memcached plus a library, database plus a library.
Right. And on the language side, you also have different execution models where there's kind of a persistent execution model like Java, Scala, etc. have C#, etc. And then there's a fire and forget model like Perl, PHP, whatever. Like, I come from nothing, I go to nothing, I'm alive for 3 milliseconds, the end. CGI
right. And
style.
if I can split the library from the data, then I can say everybody uses the same memcached like thing. And now this is just a library. And people tend to use the same database. And now this is just a library. And now all of my library-like parts can move around the system wherever because it's easy to send jars across the wire. And the data-like parts are just the in-memory cache or the durable store. And those you can get really efficient because there's not a lot of them.
Does caching validation get any easier? Because it sounds like it would be a pain throughout the entire project.
As hard as it always is. It's just one of the, the 2 hard problems of computer science, what are the naming of names, caching validation, and count off by 1 errors.
Yeah, so microservices don't have a solution for caching validation, I guess.
Well, they move it away from the core app into the microservice, who keeps his own cache and then validates it himself. But it's not in the consumer of the microservices job to deal with the microservices cache and validation.
But I just felt that a shocking number of services were essentially a cache. Yeah, a lot of services are just a cache and some cache and validation logic.
Yeah. It makes sense.
Yeah, we
And
generally
it ends up
avoided,
being a service
generally
that you now
avoided
have to
cache
babysit and monitor.
invalidation as much as possible. So I mean, when you're holding data in memory, the only way it generally works is if it doesn't have to get invalidated. So this is where like read through architectures come in really handy. Read through, write through architectures, but it basically means that the organization has to change from using kind of the 1980s model of the database as the point of integration to being the cache layer is the point of integration.
Yeah.
So, or the web services or whatever.
Guess
So you've got to lift your abstractions. So
I think I prefer the Stack Overflow model where you just get one big giant server and optimize it.
I mean,
yeah, it works
yes, I
great
may
for
be
static
over-indexing
data,
on a problem that. Sorry, I may be over-indexing on a problem that only Google, Facebook, and Twitter have. But I feel like there's a lot of companies at this point that have managed to get
There's
into
a lot
explosion
of
of
money
microservices.
in Google, Facebook, and Twitter. If you sum them up, that's a lot of dollars.
I'm not sure about Twitter, but maybe.
I mean, it was dollars when I was there.
Yeah, yes, exactly. There was a time. Who knows? Maybe he'll pull it out again and it'll come back to being dollars, but probably not.
No, revenue's only down by 50%.
From a year ago?
When the value drops from $50
Yeah.
per share to $50 total, I'll buy it
As
back.
of this past week, traffic was down 15%, but ad revenue was down 50%.
50%.
Yeah, revenue's down 50,
Wow.
traffic's down 15.
Yeah. At what time do I quit bothering to announce CCC on Twitter, on X, or whatever?
That's the problem.
I kind of feel like the heart of our
taken its
community
place.
has moved to Discord.
All right.
But enough politics.
Okay.
But I don't know if other companies have as much of we have too many microservices and we need to inline them. Because right now, the solution that I tend to see for inlining microservices is like reorg the company and put those people on the same team so that they can fold it into fewer microservices.
Right.
I don't remember where I heard this, and I don't know if the source is trustworthy, but I remember someone saying that there's way too many people at Twitter, and they all over-engineer things, and you could just like get Twitter down to like a fraction of like actual boxes.
Isn't this?
But is Twitter over-engineered?
Well, there were 7,000 people there when I was there, and there are 700 people there now. So somebody thinks so.
I'd say this was Elon Musk's hard line. Hey, that's over-engineered. There's too many of y'all. Go. And they left.
Well,
and then there was
I
no
mean,
way
that's one way to reduce the number of
over-engineer
microservices. If
When
you
he
don't
bought
have
it-
enough people to run thousands of microservices, you will no longer have thousands of microservices.
it. Yes.
When he bought it, there were 500,000 servers. So
It seems excessive. I mean, I understand that I could believe, but I think the way he went around reducing it was perhaps not the most, well, it's not my $1 billion to lose. So I don't know.
But it is a shocking number when people look at it and it's like, wait, you have 1,000 users per server. Like,
yeah, that's
how?
what I think I heard that. Yeah.
Wow.
I mean,
Like, why would you need that? Like, so few users per server.
Facebook is doing a lot more than 1,000 users per server.
Yeah. Yeah.
I think it's also a huge difference whether you're targeting your resource use on having the exact amount of processing you need to support your existing feature set, or whether you're saying, well, we over provision so that engineers and researchers can try different things and figure out what's the next big thing or how to make more money out of existing people using the platform.
So do you know what's going on with Twitter engineering now? Are they trying to reduce their microservices? Or are they floundering around in the dark just trying to keep the lights
I think
on?
they're trying to keep the lights on. I don't think there's any real engineering going on anymore there, from what
Okay.
I've heard.
Okay, fine.
So
But I don't have any friends that are still there, so they've all left. So it's all third hand now.
one thing that I consider marvelous library built for microservices is the Twitter's Finigo. This library is enabled to it's a very excellently wrote library, which has a few ports to other programming languages. So
what was the name of the thing?
Finigo, I will throw a link.
Yeah,
So
okay.
this is a library in which most of the Twitter at some point, most of the microservices is defined. I will throw a link. It's the library I started to learn on back in 2013, 14, something like that. And it's the most complete library and excellent library on the microservices to me, of course, at least. So it has a few ports to it. It's built by excellent engineers, I believe. So it's really worth looking at the main concept and how it's defined. I'll show a link.
I'm writing down a chat note into the things here for a second. And I just cloned you, Levo, without giving credit to you, but you gave no credit to somebody else. So there you go. And I totally agree with that list, by the way. That's a totally reasonable list.
So it's in the link 5, in the 5th link. So I do believe it's
Fiego. All right. Finagle.
Finagle. I don't know how
Something.
to
Right.
really pronounce
Yeah.
it.
We see if it's got something that says exciting. I've seen this before,
So,
but I haven't started enough. Actively maintained by Twitter. When did that happen? Da-da-da.
Well, a few comments. The core is actually protocol agnostic, and there is an implementation of a bunch of protocols, which is the right thing to do for a framework for microservices.
Yeah.
So it's really excellent, marvelous engineering to most of the early Twitter employees. So kudos.
Somebody did the last update 2 weeks ago, so maybe it's doing something. It's hard to say.
So the main development is, I believe, it's in the end phases. It's the maintaining phase or whatever.
Yeah.
So it's pretty much feature complete as I believe the library can. So there's
all right. Let's call that one done for the moment and see if we're doing something else here.
Okay. I'd love to get an update from Simon. We haven't heard from him in a while.
We're talking to you, Simon.
All right. Yeah. Well, I've been busy writing my RISC V backend, and it's going pretty well. So I went through the RISC V instruction set architecture document, and every instruction is basically one line of code to encode it, and that's of course a welcome change for everyone working on x86 before.
But x86 is so special.
It's a disaster. Yeah, well, we complained a lot about it already. So yeah, x86 is what it is, but also I think the impression. Sorry.
Wie sagt man auf Deutsch? What are we using English for?
Oh, geez.
Sorry?
I was just joking about the fact that x86 sucks so much is like English sucks so much, you know? It's like
yeah, and I guess
I'd never heard of like any hardware supporting RISC. Everyone just doesn't care for it.
I mean, for RISC V?
Yeah, I thought Sci-Fi was going to make some stuff, but apparently people like didn't like it, or they just never finalized any deals, and I don't know what's happening with them.
Is there somebody have a RISC V chip out?
Oh, there's a bunch. Yeah,
actual chips that are you can buy in bulk, or you can buy for demo and proof of concept.
Well, there's development boards that you can buy, and then I was thinking, and like I think Qualcomm apparently they're making a RISC V phone chip, so that runs Android.
Yeah.
So maybe there'll be some Android RISC V phones in the future.
surely there are ARM chips that they're competing against.
And
Yeah, I
there's
would
a bunch
imagine-
of companies in China that are releasing chips based on it as well, because it allows them to skirt some of the trade limitations that US and Europe have put in place.
That's what I was wondering, like, why RISC V over ARM? Like, wouldn't they be in the
Cost.
same general marketplace?
Cost.
Cost.
Right.
ARM is
ARM is
expensive.
non-free, and the RISC V is, you know, it's like
Free.
GCC. It's
Yeah.
it's
Okay.
like Emacs. No one would use it if it cost $1.
The abuse I have to live with.
Okay, Vim, whatever.
How dare you?
Exactly.
Can't win. I can't win.
All right, Simon, you were trying to put some words together, and I think we caught you unready. Do you want to say something about what you're working on or not?
Yeah, sure, I can do. Yeah, so I guess the lesson learned from the RISC V implementation, that's not finished, by the way, is that the instruction set is really nice, but at the same time, it feels really dated. It's like like in the base instruction set, there are things that are missing where I'd say, well, how many gates are that? 100 or something? It's like there's like no point in leaving that out or leaving that out or putting that in some extension, or I don't get it. And yeah, a friend of mine who also does stuff in that area said that RISC V is the perfect instruction set architecture for the kind of CPUs we stopped building 50 years ago. And it's kind of true. I mean, like if you have a look at the x86 instructions, which have like 3 input registers, an output register, and a mask register and everything, and all the RISC V stuff is basically 2 source registers, 1 target register, and everything else is really, really exceptional. And even like things like, I think, address computation is like you have to build it yourself out of multiple instructions. So I mean, yeah, the CPU will probably recognize the combination of instructions and do something fast, but it feels a bit tedious. But apart from that, it's kind of nice. I mean, the ARM has some kind of nice instruction combination of not being completely insane like x86, but not trying to be so simple as RISC V, and in the process basically being worse than necessary. For instance, I recently implemented total order comparison for floating point numbers, and the ARM implementation was actually the shortest. It was shorter than x86 and shorter than RISC V. And the reason why it was shorter was that all the bit operations like AND or XOR had an optional amount of shifts you could basically put in and encode into the same instruction. And I mean, I'm always saying like it should be orthogonal and don't mix the things, but I found it to be really, really nice because you have many places where you're combining
if you're doing bit masking, you're doing shifting
with
almost
shifts.
always. Yeah.
And if there's like one place where I'd put 2 instructions, 2 operations into 1 instruction, this would be the place I'd do it. And sadly, RISC V is like not doing that at all, I think.
The Azul TXU hardware had the bit mask included, a 5-bit shift with the mask.
Or another example, in ARM, if you want to reverse bytes, also if you want to reverse bytes on x86, you have one instruction that reverses bytes. That's it. On ARM, on the other hand, you have like this generic instruction where you can basically say, well, how much bytes do you want to swap? And based on how you set the bits, you can not only swap bytes, but you can also swap 2 bytes or 4 bytes. And that's, I think it's really, really kind of nice. And I don't remember the situation anymore.
Could you do a shuffle?
Sorry?
Could you do a shuffle with that? Like
Mm.
with that instruction, can I say instead of swapping 4 bytes with each other, can I like duplicate the first 2 bytes and the last 2 bytes? I mean, have the first bytes be the first 2 bytes of the new target, and then have the last byte be the last 2 bytes of the new target.
I'm not sure. So how would you combine them?
Oh no! So what you were saying, it sounds kind of like a shuffle, but I guess it just isn't. I'll look at
No, it's
description
not.
up.
You mean something like gather, scatter operations?
Not exactly, but SIMD has a couple of bit shuffling. So instead of using all the bits of a SIMD vector, you could just duplicate a couple of bits and move them around. That's what it sounded like you're saying, but it's
No,
not.
it's basically fixed size, the same amount of bits in, the same amounts of bits
I mean, these
out.
things show up in network path hot code, but not necessarily anywhere else. Like arbitrary bit shuffle or byte shuffle seems fairly specialized. Whereas byte swap and word swap shows up in all the network hot paths.
Byte swap and bit swap. I know bytes, but I don't know bit swap.
Any arbitrary swapping, you're like shuffle. I'm like byte swap, double word, quad word, whatever, quad byte, whatever, 2 byte, 4 byte, 8 byte, not 8 byte, but 1, 2, and 4 swaps show up in network paths, depending on the size of the data you're pushing around.
Well, I have a semi-new topic. I don't know if it's going to be fun, but does anyone want to comment about the mill CPU and RISC?
The mill? Someone did something recently of the mill?
No, but I figured that we all heard of it before.
I talked to that dude. He wanted me to do a compiler for him. Aeon Gold something or another. I don't have his name right.
Yeah, I think it's like Ivan Goddard.
Goddard.
Like
yeah. Yes. And it has some cool shit going on it. And it would have been fun to write a compiler for, but he both didn't have any money and I didn't see a market for him. So I was like, no. I would love to. It'd be fun, but no money.
Yeah, the use case sounds interesting to me, but I just figured like the RISC and the mill are probably not going to be out there.
No, the mill is unrelated, is very different from a normal CPU. I think that part is very cool. You don't have a standard 3 address, 2 address register setup going on. You have the belt thing.
Yeah, that seems really good.
Yes, and it removes a bunch of encoding bits out of instructions, and it removes a bunch of sort of arbitrarily over flexible output options, input options on registers. It fixes a bunch of things I think are interesting. That being said, I don't think he has a market yet, or he would just be yet another small, tiny embedded chip unless he hit it big and somebody could pay for the bigger versions.
Yeah, I thought that maybe servers would be interesting because you could just save a lot on costs or just double the amount of servers. But yeah, I don't know why no one wants them for servers.
At this point, you already got ARM as your competing lower cost server option, and ARM's got a lot of dollars behind it. If they can't compete against x86, why are we bothering?
So it's more of a question of, can you optimize it to be as fast as x86?
Well, you have to throw enough engineering dollars, right? I think you could if you threw enough engineering dollars in, but that's a hard you have to convince somebody to throw that much engineering dollars in, and you know, that's a hard place to win from. You have to win against x86.
Yeah, that does sound difficult.
Yeah.
So how's RISC gonna pull anything off? Because
well, you go
I
to a
still don't
market,
see a product.
right? You go to a market where x86 isn't as competitive. In this case, if you go to China, where you get locked out from rules, you pick up Chinese manufacturing, Chinese engineering. Maybe you get a cheap chip out of China because they are locked out. For them, it's cost effective. And then they're competing against ARM at first. And you go to like cell phones, you go to an embedded market that's large, but there's a lot of motion, a lot of flexibility going on. And see if you can go talk somebody into buying your chip for 1 million cell phones. And now you've made your engineering pay off.
I don't know if this is just a rumor, but I thought I heard something about like ARM will not give you a license to make chips if you start making RISC chips. But someone probably just made that up.
Oh, you know, they could, and they could also argue that, you know, it's only counts if you're seriously making big dollars into RISC chips. That one sounds like an obvious competitor message. I wouldn't like it if you were competing against me. You want to buy my stuff and also compete against me. Oh, you know, dollars will talk.
Yeah, so I guess Qualcomm have to pull it off pretty well if they're going to make the switch, because
yeah,
I can't imagine ARM being happy with them. But I don't know if ARM and Qualcomm had a fight before. Like I don't keep up with the news too much.
Let's pretend that we're not in the business of trying to sell chips. So we can pivot back to compilers a little bit. Or we could be done early. God knows I have things I got to go deal with. All right.
Let's be done early for once.
We can be done early for once. I think that's a totally fair thing to do. High quality or don't go home. All right. That's it.
All right.
Until we meet again.
Okay. Bye, guys.
Bye-bye.
Goodbye.
Yeah.